Animal migration ranks as one of nature's most visible and widespread phenomena. Every minute of every day, somewhere, someplace, animals are on the move. The migrants span the animal kingdom, from whales, dragonflies, and even salamanders. But how do researchers decode the travels of birds? Our wildlife correspondent Tanner Saul decodes this wonder in this week's edition of A Wilder View.
Throughout history, people have been mesmerized and yet baffled by the mysterious seasonal appearance and disappearance of birds. In the Middle Ages, people had imaginative speculations that suggested birds hibernate at the bottom of lakes and emerge in the spring. By the 19th century, we started to grasp this wonder by using a simple piece of metal with some numbers on it, with a method called bird banding. These birds, equipped with tiny rings on their legs, have revealed secrets about their journeys, their whereabouts, and the fate of individuals. Banding and marking birds can be used to estimate the number of birds in a population, estimate survival, and especially where these birds travel and when. Thanks to technological advances, researchers are now able to use lightweight tracking devices to follow these individuals as they migrate across the globe. This has uncovered detailed evidence about this phenomenon. These advances are not just limited to providing a description of a bird's travels. They have also allowed for the development of DNA sequencing technology that has opened up the possibility of linking information about these enormous migratory movements with in-depth analyses of individual birds at a microscopic level. And these efforts aim to identify the components of migratory behavior inherited by their parents. Understanding how this complex behavior is caused to happen remains, well, a tough nut to crack. Researchers believe it is becoming more crucial to uncover this, given that continuing global change, whether that be of climate or habitats, poses challenges for migratory birds and also for the people trying to conserve threatened animal migrations. Predicted climate data provide remarkable insights into the probable historical formation of different migration routes and the separation of bird populations. In a study using GPS backpacks on peregrine falcons, yes, you heard me right, a backpack on a bird, found the annual journeys of the peregrine populations happen within their own climate niches, meaning individuals from the same population experience the same conditions, but conditions differ between the populations. This might be one reason why individuals seem to consistently use the same routes and the same wintering grounds. The study on peregrines also suggested that a specific gene might have a role in aiding the migratory behavior of peregrine falcons. And this gene might also be functionally linked to aiding the long-term memory that could be particularly important for the populations that have to undertake longer distance journeys. Learning most likely has a role in successful migration, and this research focused on identifying inherited genetic components that might enable learning through memory formation. In the context of investigating memory formation in relation to migrations, it is probably inevitable that studies similar to the peregrine falcon research will be undertaken to compare the first migration of juvenile birds with the routes they take as experienced adults, and also following juveniles that are taught, such as in crane families. In Missoula, Tanner Saul, MTN News.
Now, if you've seen birds returning to your yard or your neighborhood, well, why don't you let us know about that? Send those pictures to us on Instagram at KPAX-TV.